Okay, so we are moving on to discrete and continuous data. That should be, you guys probably don't have the same font, but you might. Cool. Okay. This first one is kind of a review because when you draw that, it's going to lead into today's lesson. You understand what I'm saying? So, how are we going to draw this? What do I have to have on my x-axis? Time is going to go there, and how is time being measured here? What you guys said back there. So down here we're going to have days, yes? Right? So there's 1 day, 2 days. What is the range of this? Or we haven't talked about that yet. Wait a minute. We did domain and range, yeah? Okay. So what is the domain of this particular question? 0 to what? 7. 2, 3, 4, 5, 6, 7. Cool? Does everyone agree that that's good? Okay. What is the range? What is the first output value I can have? 65. 65. Does everyone agree? And that lasts for how long? For the first 3 days. $65 for the first 3 days, yeah? Right? $65 per day. So where does the line go up to day 1? Stays flat, right? If I only rent the car for 12 hours, do I still pay $65? Yeah, 1 day, $65. Got it? Now, what should I put here? An open or a closed dot? Closed dot, right. Because up to a day, I'm paying $65. What's the next range value? 130, right? Because I would have paid for 2 days. Cool? So I got to put another one here at 130. Now, what kind of dot? Open or closed? You got a 50-50 shot if you have no idea. Open? Of course it's open. Because you don't pay for that second day until that day starts. Everybody understand? So that's going to go for 1 day, isn't it? What's going to be here at 2? Open or closed? Closed. What's the next one going to be? 195. Open dot for a day. Closed dot. Now what happens? Now it only goes up by 30, yeah? So this is going to be 225, isn't it? I just did 235 because I got clumsy fingers. 225, right? Everyone agree? So we're going to start with an open dot, and we're going to go a day, and so on. We're going to run out of room, but everybody's got the gist now, yes? Now the question becomes, is this a function? First question, yes or no? It looks like it isn't, right? Because of this. This looks bad, right? Until we look at it closely and see what? It's an open dot, right? So we're cool. This is what we call a step function. And this is how a lot of things are billed. It's how they bill electricity. It's how they bill how they used to bill cell phone usage before unlimited plans. It's how they used to bill long distance charges. It's how they bill car rental. It's how they bill pizza toppings, right? There's a million things we could use an example of this in real life. You don't see it, but you see the result of knowing these functions, okay? Somebody other than you got paid a lot of money to decide how to charge you for the phone that you pay for. But this is all they're doing. Cool? All right, so now the question becomes, should I join the points on the graph? Yes or no? So you can see I'm talking about there, there, there. Should I join those points? Danielle says no. Why?
Because you're not paying all that you're paying for that number, you won't pay all the numbers in between.
Exactly. Does everybody understand what she just said? I will not pay any amount of money between 65 and 130. There's no data there. So I can't have a line there. Do you understand? Is everybody cool with that? Okay. So, should we connect the points on the dot? Points on the dot. Points on the graph. No. And Danielle says that is because there's not data for those spots. Everybody understand? It's pretty easy, right? Okay. Is it a function? We've already talked about that. Yes. Now, the reason it's a function is not the vertical line test. Okay, what's the reason it's not a function, or the reason that it is a function? What's the real mathy reason? To be a function, how many outputs must there be? One output for every input, right? And that's true, yes. For each input, I get one output. Now, finally, what is the domain and range? What's the lowest value for the domain? 0. Is 0 included? Is it possible to not rent a car? How many of you are renting a car right now? None of you. So it's possible to not rent a car, right? So 0 is included. Up to what? On this chart, we only have data up to 7. Is it possible to rent a car longer than 7 days? Yes, but we only have data for how long? 7 days. Everybody agree? Why did I use interval notation? Because all the days are included. All the time and all the day is included, yes? Even though we say 1 day, that's all the time from 0 to 24 hours, yes? Okay, good. What's the range? Can I do the range with interval notation? No, absolutely not. Why? Because you're not paying anything in between. So the range is, got to be set notation, 65, 130, 195, 225, ... because I'm too lazy to add 30 that many times. Bronwyn. The range, 0 to 10.
Because for the first 3 days it's 65, and then for a maximum of 7 additional days after the first 3 days.
No. For each additional day, up to a maximum of 7. Oh, I see. Depending on how you read it, I would read your work and I would say, oh, she read it that way. You understand what I'm saying? I read this as saying $65 for the first 3 days, then $30 per day for each additional day, up to a maximum of 7 days. I read that as a maximum of 7 total. Now, if you want to read it up to 10, you would just change this slightly, and our range would go up to 10. Yeah, you understand what I'm saying? Everybody cool with that? That's the only time that's ever been asked of me. I always just assume this means a week, because you go by a week. I'm going on vacation for a week. Interesting. Not a put down or anything, just weird. I've used these notes countless times, and everybody says, yeah, it's a week. Cool. All right. So now we have 2 new words, discrete and continuous data. You guys are smart kids. Discrete data or data is when one or both domain and or range is broken. Oops. Not Heroken. Heroken is broken because we know data. Okay? That's what it means. If you don't know or it's impossible, then it has to be discrete data. Okay? Everybody understand? Continuous data, both domain and range exist for all values. Okay, and we're going to do a bunch of examples of it right now. Okay, from a math perspective, discrete data means fractions can't occur. And continuous data, obviously all values, fractions are okay. So when you turn the page over, you're going to see some examples there, and you're going to see what I mean. Okay? So let's turn the page over. So I want to know independent, dependent variable, if it's discrete or continuous, and why. So talk about it with your neighbor for a moment. There's your two things. Decide on what are the two things being counted, because variables are anything that can change. Decide which is independent, which is dependent, and decide if it is continuous or discrete, and come up with a reason for each one. Go. I didn't eat my lunch, so I'm going to warm it up right now. And do all three, right? Don't stop after one.
So, independent would be.
At a constant person, speed of sound in air is related to
Speed of sound.
But it's related to the air pressure. No, the pressure doesn't really have anything to do with it though. It's just a saying at a constant pressure.
Meaning it's a line graph, meaning it's the same. Meaning it's going to be discrete, no, continuous.
It'll be continuous.
You could write it down, or you could wait and see what I write down to see if your answers were right. It's up to you. It depends on the level of spine that you bring to your math guessing. Yeah.
Yeah, because the
Guts.
air can be whatever it wants. It doesn't matter. Do whatever it wants.
Cojones. Ovaries. Whatever you bring. I do love that ad. Have you seen it on TV? For ovarian cancer? Where the women talk about, she does something brave, and some other woman says, man, look at the set of lady balls on her. I love that ad. My daughter was like, Dad, girls don't have balls. I know, honey. That's why it's funny. Why is it funny? Oh. Okay. Because we say you have balls if you're brave, but you don't have balls, so you must have balls or testicles. Testicles are sexual organs. You have ovaries, so girls have ovaries, but nobody wants to say you have ovaries if you're a girl, so people say you got lady balls.
So glad that was recorded.
And she looks at me in that look. And then I say, it's just funny, Dad. And she says, if you say so, Dad.
Recommended daily dose of vitamin C.
Meanwhile, my son and I
related to a female's age in years. This one would be discrete because she's not going to take like.
Are we done?
You don't know her age.
16th of a pill. You don't know her age. Her age is continuous. I mean, her age. It's
No, but you don't know the dose she's taking for her age. Recommended daily dose of vitamin C. What's the
doesn't matter
dose?
what her age is or the dose. It's just saying as she gets a year older, she'll take more. gonna jump up. It's not gonna be like a steady increase, like perfectly hit every single.
Or she's gonna take it every day, and she may run out.
No, but like it's saying the amount she needs to take related to her age. She's
Okay.
not gonna start. She's not gonna take every possible
Number
amount
one.
in between. She's gonna jump up. So
I- It's a short day. That's why it's worked out perfectly. We have this very short little lesson today because I also have a couple of tests I want to hand back to you. So, first of all, IV and DV. For the first one, what is the independent variable? Yes. Temperature is independent, which means, of course, the speed is dependent. Now, discrete or continuous? Continuous. Why? It has to hit the other ones in between. No matter what temperature it is outside, sound is still traveling, right? If it gets really cold, does the sound... No. The sound... Stop. Out. Okay? That's not how sound works, right? Everybody understand? Now, I know some of you hear me that way, but that's not actually what's happening. Okay? All right. I don't need to write why, do I? You understand why, yes? No matter what the temperature, even if it's such a small fraction of temperature that we can't actually measure it, sound is still passing. Cool? Okay. Next one. The recommended daily dose of vitamin C is related to a female's age in years. IV, DV. IV is age. Absolutely right. Why? It also depends that I have an age, don't I? Do I have lady balls? No. Okay? All right. So my DV is my vitamin. Now, this is where it gets interesting. Not vitamin. Discrete or continuous data? I have some discretes. Do I have any continuous? I have some continuous. Excellent. Argument time. Why? Why do you say continuous? Yes, you can break some tablets. I agree with you 110%. You can break tablets in half. Absolutely. Now, one sec. We're on their turn right now, Danielle. So, how old are you? 15. You would take a certain amount of pills, yes? When would you change your dose? Tomorrow you're going to be older than today, aren't you? Aren't you? So are you going to take a 1 grain of vitamin C more?
No.
Yes or no? No. Right? You understand what I'm saying? Does everybody understand what I'm saying? I'm well aware of that because the dosage changes every year, not every millisecond of the day, does it? Right? Everybody understand what I'm saying? You have to look at this. You have to look at the situation, right? So this is discrete because even though you always have an age, right? That age, you only change the dose at certain points during that age. Understand? If you look at the side of cold medicine, it's always like children under 12 take this much, children over 12 take this much. The change is at 12, right? If you're 11 and your birthday's tomorrow, are you 12? No. Right? Everybody cool? Okay, next one. Number of cans of juice is related to the cost. What's IV? What's DV? Juice is IV? Is it? Yes, of course it is. Juice. DV is cost. Discrete or continuous? I didn't hear that option. Discrete or continuous? Yeah. Exactly. You cannot go into Safeway and say, I would like to buy this drink. Glug, glug, glug. I am no longer thirsty. Here, I would like some back. I wish you could because I accidentally bought me some mango coconut water. I told you, you would think it would be delicious. Tastes like dog food. I only know why dog food tastes like dog food because I've eaten dog food. Canned. Never mind. I have a life, you know, Navneet. And sometimes your life requires you to do stupid things. My life more often than others. And of course, you must remember, I've had almost 42 years of that life. Aye, it does. So this is discrete because, of course, you cannot go to Safeway and say, I'm only half thirsty. So I only want a half a can of juice. Well, you can, but they won't take it back. Right? Okay. And finally, altitude is related to temperature. What's the IV? What's the DV? Altitude is the IV, temperature is the DV. Discrete or continuous? Continuous. Now, this is where it gets a little weird, though, because if you were going to graph it, can you take a temperature measurement at every possible fraction of an altitude? It would be impossible, wouldn't it? Right? You can go to top of Mount Everest, take the temperature, come down 10 meters, take the temperature, down 10 meters, take the temperature. Do you technically have data for in between? No, you do not. But, common sense, there is indeed a temperature there, isn't there? Everybody got it?
Yeah.
Picking up what I'm putting down, read my mail, mow my lawn? Excellent.
Did you know that the standard atmosphere temperature raises by 1.98 degrees Celsius per Celsius?
Ground school time.
I was quizzing her at lunch.
I see. All right.
VA.
I just want to see how long this is.
Yes. Name of the other phone.
Which other
I
phone?
got it the first one. F you.
Oh, I don't remember.
What's the name of this one?
This one is
Remember
Char.
that one? What was it?
Char BB.
Fun altitude.
Of course you can. All right.
Bugging me now.
This next one, guys, I'm not going to give you, I think I have an outline for discrete and continuous data. I don't. Good. Because it's pretty darn easy. There's a bit of it on page 295. I don't really care. Right? You all got it. You heard that, yeah?
Yes.
Okay. You all got it. You did fine. I'm not worried about it. So, I would like to move on to linear relations. You already learned about linear relations last year. Yes, you did indeed. So, we're going to take what we just talked about and we're going to apply it to something that you learned last year, but we're going to fine-tune what you learned last year to make it jive with what you just learned right now. Okay? So, graph this on there. Just sketch it. Go. While I make some tea. Sam, I'm going with organic Earl Grey cream of Earl's Grey.
Earl's Grey. Belongs to Earl. But it actually doesn't.
It smells lovely. How much should I use?
All of it.
We ran
1
out
to
of
2 perfect spoons.
That's what you
I like it strong. Bronwyn, I'm using my brute. I know it works. I used it yesterday. I'm so glad none of you are obsessive compulsive when I say sketch a graph. You are just sketching. I used to teach a kid that would have to get out a ruler to do this question. It took him 30 years.
I actually used to do that kid with
Somebody set a timer for me.
How long?
How long?
7 minutes. I like a strong tea.
Okay. How many toppings can you get on a pizza?
All of them.
All of them. The entirety of the pizzas. All right. So what goes on the bottom? Toppings go on the bottom, of course, because toppings are the independent variable. Now, 1, 2, 3, 4. Will it go on forever? Eventually, you'll run out of toppings.
The earth. It's still the earth.
Okay. All right. Yes. Okay. Pizza Hut has infinite toppings. You're right. I would like star fruit on my pizza, please. Okay. What goes on the range? Price. What is the lowest price? $12. What's the next price? $13.50. Next price? $15. I'm gonna stop there because that's all we need. Yes. How much is if I don't get me any toppings on a pizza? $12. Even though somebody always argues right now, cheese counts. No, it doesn't. Neither does tomato sauce. Because once you put tomato sauce and cheese on it, you have pizza. Before you put tomato sauce and cheese on it, you have bread. Okay? Okay. So 0 to 1 topping is how much?
0 to 1.
$12. Right? So if I have a 1 topping pizza, it's going to cost me $12. Right?
No. Yes.
Yes. I would like to add a second topping.
Okay.
I would like to add pepperoni. So how much is it going to cost me? $13.50. Since you are all kids, one of you wants ham and pineapple,
Yep.
which is the grossest pizza. Not excuse me. End of discussion. It is gross. They have no place being on a pizza together.
Well, if you make it the Hawaiian pepperoni, then there's bacon.
When you guys grow up, you will start to understand how disgusting ham and pineapple pizza is. It's a kid pizza. You will outgrow it.
No.
Yes, you will.
I need to come to you 30 years, Mr. Byers, and I'm like, I still like ham pineapple pizza.
You're crazy in the head. Now, stop. Obviously, we can keep going, yes?
Yeah.
What is going to happen every time we move 1 topping on the range, on the domain? What is going to happen to the range?
Goes up.
By 1.5. Everybody got it? How long will that continue? Until we run out of toppings. Right? Forever, ever, and ever. Right? Till we run out of toppings. Now, the question becomes now, do I draw this line? Why?
1.5 toppings.
You cannot get 1.5 toppings. Now, somebody always says, yes, you can. You can get half pizzas. I get it all the time. They still charge you for the whole pizza topping, which means you have to be smart. I want a pepperoni pizza, but I only want pepperoni on half. And don't you be giving me only half a piece of pepperoni. I want all the pepperoni that you were going to put on the whole pizza, but I only want it on half. Picking up what I'm putting down? Don't get gypped out of half your pepperoni because the pizza guy is cheap. Because they all are. I know this. I used to work at a pizza place. What? Of course you do. Yes, of course you do. When I first worked at my first pizza place, I took an order. The guy's like, yeah, I want half pineapple and ham and half pepperoni and mushroom. I'm like, just order 2 pizzas. But I didn't say that. Okay, no problem. So then I went and I said, I got to make this pizza. It's half ham, pineapple, half pepperoni, mushroom. And the pizza guy says, okay, take the crust, pinch the crust. So that makes your line. Okay? Just wait. I'm going to tell you. And the pizza boss says, okay, here's what you do. They only want mushrooms on half the pizza. So normally we take this cup, you'd fill it with mushrooms, you dump it on the whole pizza, right? Don't do that. They only want it on half. So only pour a little bit of mushrooms on half the pizza. And I was like, but they want mushrooms. They're paying for mushrooms. He's like, I don't care. You're going to charge them for mushrooms, but you're not going to give them the whole pizza's worth of mushrooms. Same with the pepperoni. He's supposed to put 20 slices on a whole piece. He says put on 10. But he's paying for 20. I don't care. Because pizza guys are cheap. No. This is 4 toppings.
If I order pizza, it would be the same price as ordering one of the same pizza.
Yeah. All right. We will argue pizza toppings later. It is math class.
Our class. The first way to go to order pizza one day and actually test
And see, test it out.
Yeah.
All right. So, here's some stuff that you already know. 1, linear relations. Linear relations. This messes kids up. I didn't draw that line. Is this a linear relation?
Maybe.
Yes, it is. Okay? You don't need the line. It need not be continuous data to be a linear relation. What makes it a linear relation? Yes. The change in independent variable and the change in dependent variable result, it's the same every time. Now, when I say it that way, somebody always says, but this wasn't the same. It was 1 and 1.5. That's not what I mean.
It's been 7 minutes.
Oh, thank you. It means that for every 1 I go on the range, I go up 1.5. If I go 2, I would go up 3. Okay? They don't have to be the same, but the change in each has to be the same. Is everybody okay with that? Oh, Bronwyn, you were right.
Yep.
I had to be very careful. Everybody understand what Bill has said for us? Because Bill was 100% correct. The thing about the change has to be the same.
The change has to be used.
Are we applauding Bill? Nice! Good job, Bill. Take a bow. Ladies and gentlemen, Bill. He'll be appearing here until the end of the month. Tip your waitress. Woo!
15% at least.
See how I spilt that much tea on the way over here? That's why I'm not a neurosurgeon. No, the real reason I'm not a neurosurgeon is because I was too lazy to go to science class. Where's my magic pen? Oh. But in retrospect, I'm able to say I'm already shaky.
I'm thinking someone they're hiking up and trying to spill tea on their head.
All right, so linear relations, the IV change results in a predictable and constant dV change. Okay? They need not be the same, but they must be predictable and constant. Okay? So, let me give you an example. X, Y. 1, 4, 2, 8, 3, 12. Is that a linear relation? Yes. Right? Because every time I go up 1, the Y value goes up 4. Got it? Everybody cool? Okay. What about this one? X, Y. Linear relation or not? Yeah, it is. Why?
Side is
Because this time I jumped by 2, didn't I? This time I jumped, so that one I jumped by 10. When I jumped by 1, I still jumped by 5. Got it? Everybody good?
yeah.
Okay. So, you now know there are 2 ways to show a linear relation. One is in words, which is written in your notes, yes? The question has a linear relation. So that's one way to show a linear relation. The second way is a graph. You drew a graph. You already knew it. The third way is the table of values. That's what I just did, right, with X and Y. That's what you learned in grade 9. So this table of values was toppings and cost, yes? 0, 12. 1, 13, 50. 2, 15. Right? Everybody cool? You learned that last year. And finally, with an equation. This is where you should have ended your discussion last year. I need an equation. What happens here? This is plus 1.5, yes? This is plus 1.5, yes? This is plus 1.5, yes? What's the shortcut to adding the same thing over and over and over again? Multiply. So I take my 1.5 times toppings plus how much? 12. And that equals my cost. That's the fourth way to show a linear relation. Is everybody cool with that? Everybody's good? That's all grade 9 stuff, yeah? At least it should have been. Okay? So remember, linear relations are any relation where the IV and the dV change in the same proportion. Proportion over the entire domain and range. Is everybody cool with that? Okay. Does it have to have a line? Does it have to be continuous? No. Everybody good? Okay. What time is it? Oh, we're doing just fine. Now, I think your guys' notes get a little mucked up here, or does it look like this?
Looks like that.
Excellent. Good. So, is this linear? Yes or no? Yes. Why? Plus 5, plus 9. Plus 5, plus 9. So that is linear. What about this one? Yes or no? No. Obviously not, because that's plus 5, that's plus 75. So this one's plus 5. If this were linear, what would this have to be? It'd be plus 75, so it'd be 150, right?
Yeah.
But it's not. So that's not linear. Everybody cool? Okay, so that's one of our 4 methods out of the way. I can look at a table of values and I know if it's linear or not. Cool? All right. Now we'll try it with equations. Linear or not? How are you going to decide? You could graph it, or you could do a table of values, or you could just use your brain, yeah? Which of those is input, X or Y? X. So start with 0. If X is 0, what's Y? 4. When X is 1, what's Y? 6. When X is 2, what's Y? 8. It's going up by a pattern, isn't it? So that's linear. Right? There's a bunch of white space here for a reason, trust me. What about this one? Can you do that one in your head? It's a little bit harder, but let's try. X, Y. When X is 0, what's Y? -1. When X is 1, what's Y? 3. Okay, so that means if this is linear, this next one should be what? 7, right? When x is 2, what is it? I heard someone say it. It's 15. Is that linear? No. So now look at what here is our difference. What's different between B and C? The exponent. Anything with exponents can't be linear. That's what we call a quadratic, which you are going to learn to death next year. But I'm awakening you to it now. So that's the next trick to remember in your head, yes? If there's an exponent, it's not linear. D, that's a graph, linear or not? Yes. How do you know? It makes a straight line, right? Easy peasy. What about E? Of course it turned off. Yes, E is linear, but somebody always says, but Mr. Myers, you said a linear equation has to change the dV and the IV. No, I said that the change has to be predictable and in a pattern, yes? So as my IV goes up +1, what does my dV go up by? What does my dV go up by? 0. And is that consistent?
Yeah.
So it's linear. So my x is going up by +1, my y is going up by +0, consistently. Cool? And F. Linear or not?
No.
No, non-linear. And G, linear. Now I want to do one last thing and then I'm shutting up. You're going to work, and I'm going to give you back a couple of pieces of work that you have given to me. Make a table of values, make a table of values. Graph this. Now, I don't know if you remember grade 9, but I'm going to explain this. I'm going to remind you. Whenever you make a table of values, you need to do at least 3. After this year, you're going to want to do 5. You need 5 independent variables to sketch a graph. So we're going to use 5 here. Which do I input? Do I put in x's or y's? X's. I choose 5. I always choose -2, -1, 0, 1, 2. Always. Then you cover both sides of the origin. Yes? So when it's -2, what is my y value? Zero. Now you guys are smart kids, yes? You know this is going to be a linear equation, right? Why? Because there's no exponents. So as soon as you know this next point, can you fill in the rest of the chart without even thinking? Yeah. What's this one? 2. So that means I'm going up by what? 2. So what's this? Then what's this? Then what's this? Who do we appreciate? Math! Math! Rah, rah, rah! Because I know you all appreciate math. It's your favorite. What about this one? -2, -1, 0, 1, 2. What's -2 squared? 4. What's 4 minus 3? 1. What's -1 squared? Minus 3? What's 0 squared? 0 minus 3? -3. That's looking linear, isn't it? But we know it's not linear, don't we? Why? Because it has an exponent. So what happens at 1? What's 1 squared? Minus 3?
Minus 2.
What? 2 squared?
4.
Minus 3?
1.
1. Crazy talk. Graph them. This one's easy. Choose any 3 points and make a line. Easy peasy, lemon squeezy. Done. This one. Where do I start? 0, negative 3. 1, negative 2. Okay. Negative 1. What? 2. Positive 1. 1. It makes this fun U shape, which we call a parabola. I wanted to show you guys that. Even though in grade 10 you only need to know how to do lines, I want you introduced to parabolas, because next year they are your bread and butter. And they are your bread and butter in physics class. Because most of the stuff you do in physics is not linear. Everybody cool? All right, I'm done. On your outline, we have covered up to page 308. If you've been doing any work at home, if you feel that you're a little like, I could use a bit of practice, that's where to practice. Okay? If you're like, no, I got this. This is grade 9. Come on. Put your head out of your butt, Myers. Don't bother. Okay? If you're somewhere in between those two extremes, then do a little bit. Okay? Now, I just want to pause.